Can you calibrate your own electrical test equipment safely? Imagine this. You have a multimeter or a clamp meter that you're relying on daily, and you wonder if you can check its accuracy yourself. Well, calibrating electrical test equipment is a key part of making sure your measurements are correct. It involves comparing your device to a known standard to see if it reads accurately. But the big question is, can you do this safely on your own? The answer depends on a few important factors. First, calibration is necessary because all measurement tools can drift over time, especially after heavy use or exposure to harsh environments. If your equipment isn't properly calibrated, it might give you wrong readings, which could lead to safety issues or faulty work. For example, a misread voltage could cause an electrical shock or damage sensitive equipment. Regular calibration keeps your measurements trustworthy and helps meet safety and quality standards. To do this calibration yourself, you need access to reference standards that are more precise than your device. These standards are often called calibration references or standards. They are traceable to national or international measurement systems, meaning their accuracy is verified and recognized worldwide. For example, calibrating a multimeter involves checking its voltage, current, and resistance readings against a high-precision calibrator. Adjustments are made if the readings don't match within the specified tolerances. Safety is a big part of the process. Working with electrical equipment involves risks like electric shocks, burns, or even fires. Before starting, you should perform a risk assessment to identify hazards. Always wear proper personal protective equipment, such as insulated gloves and safety glasses. Make sure your work area is dry, free of conductive materials, and well-organized. Follow lockout and tagout procedures to ensure the equipment is turned off and de-energized before you begin. If you're working with high voltages or in hazardous environments, only use equipment rated for those conditions and follow safety guidelines strictly. The practical steps for calibration include selecting the correct test mode, connecting your device to the reference standard, applying test signals, and comparing the readings. If there are discrepancies, you can make adjustments following the manufacturer's instructions. It's also essential to document everything: the test conditions, readings, adjustments, and results. This record helps with quality control and compliance with regulations. However, calibration of complex or high-voltage equipment often requires specialized tools and knowledge. Mistakes can damage your equipment or cause injury. Environmental factors like temperature and humidity can also influence your results, so controlled conditions are best. Some devices might need internal access or disassembly, which can void warranties or introduce additional risks. In professional settings, equipment used for safety-critical tasks or high-precision measurements should be calibrated by accredited laboratories. These labs have traceable standards, proper environments, and trained technicians to ensure accuracy. For simple tools like handheld multimeters, if you follow proper procedures and safety practices, you can often calibrate them yourself. But always remember, when in doubt, consulting a professional is the safest route. In summary, you can calibrate your own electrical test equipment safely if you have the right knowledge, tools, and strict safety procedures. But because of the risks and the need for precise standards, many times it's better to relying on professional calibration services for high-stakes or complex equipment. Knowing how to properly calibrate and understand your tools is a fundamental skill in electrical engineering, helping keep systems safe and measurements trustworthy.